Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all. Welcome back to Managerial Economics, Eco 556. Well, in the previous week, we have learned on how to estimate and analyze demand. As you can see, knowledge in this area allow managers to not on to forecast and predict the future demand. Now, apart from demand, another important thing that managers needs to focus would be in terms of how to produce. So when we talk about how to produce, we are referring to the method of production. Now, for any managers, because they want to maximize profit, so their main concern is to identify how best they can produce the product using the least cost technique. So in this chapter, theory of production, what we plan to do is to identify the optimal method or the cheapest method to produce a product. Well, so let us look at the topics that will be covered today. So basically we're going to start off by looking at production function. And because production can be divided into short run and long run, what we intend to do is to identify how to minimize costs when firm produce in the short run. So this requires us to look into production in the short run. So there are several concepts that we're going to look at. So we're going to look at the total, average and marginal product concept, followed by law of diminishing returns, and then stages of production, and the last one would be on optimal input usage. Now the second part of this chapter, looking at how to decide on the usage of input in the long run. So this would be production in the long run. But what we're going to do today is only focusing on short run production, and we are trying to identify what would be the best number of inputs to use in the short run. Alright, so let me start off by introducing to you what production is actually. So when we talk about production, production is a process, where firms convert inputs into output. And when we talk about inputs comprises of land, we have labor, capital, and entrepreneurial ability. So all these resources are converted into output in the production process. Now, the production function is actually a mathematical function that tries to show the relationship between inputs and the maximum amount that can be produced within a given time period, given level of technology. So a production function tries to translate the production process into a mathematical terms. Now let us look at how does the production function looks like. Now the production function can be expressed mathematically by Q. It's a function of x1, x2, where Q is the level of output, and the axis actually present the inputs that we use in the production process. Now the level of technology is represented by the functions. So this is how the production function looks like. Now, as I mentioned to you just now, there are different types of inputs, ranging from land, labor, capital, and entrepreneurial ability. But in this course, we tend to simplify things by considering only two resources. So we are going to consider only two resources, namely labor and capital. So in this course, when we talk about production function, so we're gonna write the production function in the form of L and K's. So Q here represent output. L is labor, and K, it represents capital. Now Now that we have looked at the production function, what we're going to do next is we're going to look at the different types of inputs that we have. Okay, now when we talk about inputs, these are the resources we use in the production process. Okay, now inputs can be further categorized into variable or fixed, depending on how readily their usage can be changed. Okay, so what's the difference between variable input and fixed input? When we talk about variable inputs, so these are inputs which you can change the quantity with the level of output. Okay, meaning that when you produce very small units of output, you use small amount of or very low amount of variable inputs, but as output increases, you're going to increase the usage of variable input. Okay, now when we talk about fixed input, these are inputs in which the level of usage you cannot change. Okay, so it doesn't matter how much you produce, but the amount of fixed input that you use is going to be the same. Okay, so meaning that if you're not producing anything, but you still need to pay for the cost of this fixed input. Okay, so these are the inputs that we have in the production process. Okay, so we categorize them as variable input and fixed input. Okay, now when we want to discuss production, it is very important for us to distinguish between the two time frames, namely short run and long run. Okay, so what's the difference between short run and long run? Now in economics, when we want to distinguish between the two period of time, it's not in terms of the number of months or the number of years, but actually it is in terms of the type of inputs that you use. Okay, so let us look at what short run is all about. So the short run production function describes the maximum amount of goods and services that can be produced by a set of inputs, and these inputs comprise of both fixed and variable inputs. Okay, so in other words, in the short run, you are going to use both inputs, variable inputs and fixed input. Okay, now what about the long run production period? Now in the long run production period, what happens is that the inputs that you use are going to be variables. Okay, so there are no element of fixed input available. So let me give you an example. Okay, so let's say in your production you are using two resources, namely labor and capital. Okay, now in the short run, capital tend to be fixed, because it is very expensive. That means it is not easy for you to increase the quantity in a short period of time. But when it comes to labor, it is very easy for you to change the quantity. What you can do is either you encourage your worker to work overtime, or you can hire more labor. So here we are saying that in the short run, capital is the fixed input, labor is the variable input. But when we are talking about the long run, so both inputs will become variable. So not only labor is already the variable inputs, but capital will also become variable inputs, because in the long run, firms have ample time to accumulate enough resources to get this capital. Okay, so in the short run, your inputs can be both variable and fixed, but in the long run, the fixed input will become variable inputs. Okay, now let us start by looking at the production in the short run. Now remember that our main aim in this topic is to determine the number of resources to use in the short run. Now because in the short run you are using fixed input and variable inputs, so we are not very much concerned about the fixed input, but we would like to know what is the ideal number of variable inputs to use. Okay, so that is the main aim of production in the short run. Okay, so when we want to analyze production in the short run, there are several concepts that we're going to look at. Okay, so we will start off with the concept of total product, moving on to marginal product, and the last one is going to be average product. Okay, so let us look at the definition of each of these production terms. Okay, now when we talk about total product, okay, this is the same thing as output, okay, in the short run. So total product and output is the same thing. Okay, so total product, okay, is also, okay, representing the short run production function. Okay, next is the marginal product. Okay, now the marginal product of a variable input will tell you the change, okay, in total product when you change your variable inputs by 1 unit. Okay, so marginal product will tell us how much input will change as we change the level of variable input. Okay, so that's the concept of marginal product. Next is average product. Okay, now average product actually represent total output divided by your variable input. Okay, so in other words, okay, average product will tell us on average how many units of output can be produced by each of the variable inputs that you hire. Right? Now consider the two inputs. Okay, so you have production function, okay, which is a function of x and y. Okay, now x is your variable inputs, okay, and y is your fixed input. Okay, so if we want to calculate marginal product, okay, so if we want to calculate the marginal product just now, so what we need to do is we need to find, okay, the changes in output, okay, divided by the changes in variable input. Okay, but if you want to find, okay, marginal product function, what you need to do is you need to differentiate, okay, the total product function with respect to your variable input x. Okay, now when you're doing this, you are holding the other inputs y as constant. Okay. Next is average product. Okay, so average product is defined as total product divided by variable input. So meaning that, okay, the formula to calculate it is going to be q, okay, divided by your variable input x. Again, you are assuming that y is constant. Okay, so to summarize, okay, so when we talk about total product, so it is referring to your total output, and it is a function of your variable input because you cannot do much on your fixed input. Okay, marginal product is defined as the change in total product divided by your by the increase in your variable inputs, in this case labor. Average product is total product divided by your variable input L, and production or output elasticity, okay, can be measured by taking marginal product divided by average product. Okay, now let us look at a table, okay, and this table simply shows the combination of labor and capital, okay, that can produce different level of output. So from this production table, so you can actually get to know, okay, the different combination of inputs to produce certain level of output. So for example here, if let's say you want to produce, okay, 47 units, okay, of output, what you can do is you can use 5 units of capital and 2 units of labor. Now there is another alternative, okay, to produce 47 units of output. So if you move here, you can see that, okay, you can see that to produce 47 units of output, you can also use 2 capital and 5 labor. So it is up to the firm, okay, to decide in terms of what is the combination of inputs to use. Okay, now as I mentioned to you just now, what we are trying to do here is we are trying to determine the ideal number of inputs to use in the short run. Okay, and in the short run, there are two types of input: fixed input and variable input. Now, so here we have two inputs. Okay, so we have capital and labor. Now, in the short run, okay, usually capital is held fixed. Okay, so it is considered as the fixed input, while labor is the variable input. Now, so based on this production table, so what we're going to do is we're going to fix the amount of capital. So this would be the amount of capital available, okay, in the short run. Okay, but when it comes to labor, the firm is allowed to change the number. Okay, so as you can see, these, okay, so the blue values here represent the different level of output, okay, when you change the level of the number of labor. Okay, but nothing much can be done on capital because capital is the fixed input. So let us convert this into this information and put it, okay, in a table form. Okay, so what's happening is that because we cannot do much on capital, so we're going to assume that capital is fixed, okay, at 2 units, okay, but labor, you can vary them. Okay, so what I'm going to do here is I'm going to construct a table, and I'm going to put on one column the variable inputs. Okay, so we're going to have values from 0 up till 8, and I'm also going to construct the total product, okay, column based on the production table which I have shown you in the previous slides. Okay, so these are the corresponding, okay, values of output, okay, based on the different level of inputs. Now, what we would like to do is, okay, we would like to know what is the contribution of each of the labor that we have hired. Okay, because looking at this table, the current table that we have only tell you the total output, okay, available in the company based on the labor that you hire. But what we would like to know now is the contribution of the labor that we hire. Okay, all right. Now, this brings us to the concept of marginal product. Now, if you recall just now, marginal product allows us to identify the extra output generated by each additional labor that you hire. Okay, so if you can see here, okay, when labor is 0, total product is 0. Okay, so when you have no worker, so that means nothing can be produced even though you have the machine, isn't it? It's because nobody is operating the machine, so nothing is being produced. So if you want something to be produced, you need to hire labor. Now, when you hire one labor, you can see that production becomes 8. So what is the contribution of the first labor? So you can see that the contribution of the first labor is actually 8. Okay, because previously when we don't have worker, production is 0. So it must be the case that the first labor contributes 8 towards production. So the contribution of this worker is what we call as marginal product. Okay, so you can continue, okay, calculating, okay, marginal product for each labor that you hired. Okay, so for example, when you take in the second worker, production becomes 18. Okay, so what is the contribution of the second worker? Well, when you refer to the first worker, you can see that when we only have one worker, production is only 8. But when you have 2 workers, production becomes 18. That means it must be the case that the second worker contributes 10 towards production. So 10 is what we call as marginal product. Okay, so what I have here, okay, is a complete, okay, column for marginal product. Okay, so every time I add in labor, I try to calculate, okay, the contribution of each labor. So for example, if let's say initially you have 5 workers, okay, and total output in the company is 47, but when you hire 6 workers, the total output produced has now becoming 52. So if you want to know what's the contribution of the 6th worker, or in other words the marginal product, so you'd find the difference, okay, between output for 6 workers and output for 5 workers. So as you can see, okay, the marginal product is equals to 5. Okay, The next thing that we're going to calculate would be average product. Now, if you can recall just now, when we talk about average product, we want to measure the average output produced by each variable inputs. Okay, so meaning that, okay, to calculate average product, you have to divide output by the variable input. Okay, so when labor is 0, definitely total product is 0. You cannot calculate average product. But when you hire one labor, total product is 8. So to calculate average product, simply divide 8 by 1 and you're going to get 8. Okay, the same thing for the second worker. So when you have 2 workers, production becomes 18. So if you want to measure the average product, so all you need to do is divide 18 by 2. So you're going to get 9. So this means that on average, okay, when you have 2 workers, on average, each worker will produce 9 units. Okay, so these are the corresponding values of average product for different level of variable input. Okay, now what we're going to do next is we're going to sketch, okay, all the production curve based on the data that we have. Okay, so we have looked at total product, marginal product, and also average product. Okay, so what we're going to do is we're going to sketch all this diagram. Now, when we want to sketch or plot, okay, the production curve, bear in mind that all curves have an inverted U shape. Okay, so it comes to no surprise when you plot all the points, okay, of your production curve, you can see that all exhibit an inverted U-shaped curve. Okay, so as you can see here, the top panel, you have the curve for total product. Okay, for the lower panel, okay, so you have the average product represented by the blue curve and the marginal product represented by the black curve. Okay, now you can see that, okay, when marginal product, okay, is positive, okay, total product, okay, is increasing. Okay, so you can see that when marginal product values here are positive, so total product is increasing. Okay, but when marginal product becomes negative, total product is decreasing. Okay, and total product, okay, reached maximum point when marginal product is equals to 0. Okay, now why is that the case? Well, the thing is, marginal product, okay, measures the change in total product, okay, when you add in 1 unit of variable inputs. So in other words, marginal product measures the slope of the total product curve. So as you go along the total product curve, you can see that initially, okay, total product increase at an increasing rate. So you can see that the curve is very steep. Okay, but as you increase the level of inputs, okay, you can see that total product increase but at a decreasing rate. So this is represented by a much flatter slope. Okay, and when total product falls, you can see that the slope becomes negative. So that's why marginal product is negative. Okay, now let us look at the relationship between marginal product and average product. Now as you can see here, when marginal product is greater than average product, okay, in other words, marginal product is above average product is increasing. Okay, now when marginal product is less than average product, in other words, the marginal product curve is below the average product curve, you can see that average product is falling. Okay, and when marginal product equals to average product should be maximized. So now that we have looked at the 3 production concepts, namely total product, average product, and marginal product, the next concept which is important for short run production is the law of diminishing marginal return. Okay, what actually is law of diminishing marginal returns? Now the law of diminishing returns states that as additional units of variable inputs, okay, are combined with a fixed input, you're going to reach a point whereby the additional output starts to diminish. Okay, so in other words, in the short run, okay, remember that you are using 2 types of input, variable inputs and fixed input. So when you want to add production, definitely you want to add in your inputs, isn't it? But the only inputs that you can add would be the variable inputs. Okay, fixed inputs remains the same. So when you continue adding your variable inputs to your fixed input, there gonna comes a point whereby the contribution of your variable inputs will decline. In other words, okay, the additional output starts to diminish. Okay, so let us look, okay, at how we determine diminishing return. Okay, so remember that just now we have already established, okay, the column for marginal product. Okay, now if you look at this production table, okay, you can see that as input increases, okay, now total product increases and marginal product increases. Okay, so when you increase inputs, okay, from 0 up till 3 units of labor, you can see that marginal product also increases. Okay, now this is known as increasing return. So when the contribution of each labor increases, so this is known as increasing return. But when you start adding in more inputs and the contribution of each input falls, now this situation is what we call as diminishing returns. So as you can see, okay, after, okay, the so this is the first unit, second, third. Okay, so after the third workers, okay, you can see that the contribution starts to fall. Okay, so this is what we call as diminishing returns. Okay, so given your marginal product curve, you can see that when your marginal product curve increases, so this is what we call as increasing returns. So one of the reason why, okay, firms are experiencing increasing returns is because there are teamwork, okay, there's specialization, people become more efficient. Okay, but when marginal product falls, so this is what we call as diminishing return, and you can see that diminishing returns happens after the maximum of marginal product. Okay, so why do we have diminishing return? So as I said just now, because fixed input are limited in quantity, so there are fewer opportunities for teamwork and specialization, and for that reason the contribution of the variable inputs that you add starts to decline. Okay, now that I have already introduced you, okay, with the concepts of short run production, we have looked at total product, marginal product, average product, and law of diminishing margin return. The next thing that we're going to do is we would like to know what is the ideal number of variable inputs to hire in the short run. Okay, so to find answers to this question, we need, okay, to visit, okay, the 3 stages of production. Okay, so the 3 stages of production is established, okay, based on the production curve that we have. Okay, so let us first look at what are the 3 stages, okay, and then we're gonna look at the production curve again and identify the 3 stages. Okay, so production stage can be divided into 3 areas. Okay, now stage 1 starts from 0 units of variable inputs up to the point where average product is maximized. Stage 2 starts from the maximum point of average product up to the point whereby marginal product is equals to 0. And stage 3, okay, started from the point whereby MP equals to 0 onwards. Okay, so beyond the point whereby MP equals to 0. Okay, so what I have here is a much smoother version of the production curve which we have looked at just now. Okay, so again on the top panel we have the total product curve. At the lower panel we have marginal product curve and average product curve. Okay, now this production diagram can be divided into 3 areas. Now as I mentioned to you just now, stage 1 starts from 0 labor up to the point whereby average product is maximized. Okay, so represented by this line. Okay, now stage 2, okay, is from the maximum point of average product up to the point whereby marginal product is equals to 0. Okay, so this line actually. Alright, and stage 3 would be beyond the maximum point whereby marginal product equals to 0. Now, so when you look at these 3 stages, okay, so remember that our main aim is to identify what is the ideal number of labor to hire. Okay, so let us start, okay, from the point of origin, and we're gonna slowly add in labor and see what will happen to output, marginal product, and average product. Okay, now in the first stage of production, you can see that when you continue adding labor, okay, total product increase. Okay, now in terms of marginal product, you can see that marginal product also increase. Okay, but after point G, you can see that marginal product starts to fall. Okay, so meaning that in stage 1, diminishing return has already begun. Okay, so the question is, should we stop hiring labor in stage 1? Okay, because the thing is, the law of diminishing marginal return has already begins. So, but when you look at the average product, you can see that even though diminishing return has already begun, but average product keeps increasing. And for your information, average product also represent productivity level. Okay, so based on this, okay, you can see that it is not wise for the firm to stop hiring labor in stage 1, because when you keep adding labor in stage 1, okay, productivity is greater than before. So this shows that you should continue hiring labor, okay, until you reach stage 2. Okay, so you shouldn't stop in stage 1. Now, once you reach stage 2, you can see that, okay, not only marginal product falls, okay, so marginal product continues to fall, but average product or the productivity level, okay, starts to fall. Okay, so should we stop in stage 2? But when you look at the production curve, you can see that production continue to increase. Okay, so if you continue adding labor in stage 2, even though average product and marginal product falls, but production increases, and this can contribute towards your sales. Okay, so based on that situation, well, in stage 2, you can simply add in labor, but the last point would be the point whereby marginal product is equals to 0 or your total product is maximized. Okay, so this would be the last point you should hire labor, because if you continue to hire labor in stage 3, what happens is that, okay, your total product will fall. Okay, your productivity keeps decreasing and your marginal product becomes negative. Okay, so you are hiring more labor, incurring more labor charges, but you are producing less. Okay, so if you know you want to produce less, might as well you produce somewhere here, isn't it? And you incur less labor cost. So looking at this situation, you can see that stage 3 is a strict, okay, no area. So basically you are prohibited, okay, to produce in stage 3. Okay, you're gonna incur a loss. But when it comes to stage 1, if you stop hiring labor in stage 1, you can see that you're gonna lose in terms of productivity level. So the best stage, okay, of all 3 would be stage 3. Okay, so if you're talking about what would be the amount or the ideal amount of labor to hire, it should be somewhere within stage 2. Okay, so this is another diagram for the stages of production, but this time around I try to explain what actually happened within the stages. Okay, so we have here marginal product curve and average product curve. So as you can see in stage 1, what happened is that fixed input is grossly underutilized. Okay, specialization and teamwork will cause average product to increase when additional, okay, variable input is used. Okay, now in stage 2, you can see that specialization and teamwork continues, okay, as a result of greater output, when additional variable input is used. Okay, so in this stage you can see that fixed input is being properly utilized. Okay, now in stage 3 you can see that fixed input capacity is reached. Okay, so additional variable inputs will cause output level to fall. So looking at all the 3 stages, the best stage is going to be stage 2. So in the short run, okay, so any rational firm, they should only operate in stage 2. Why stage 2? Why not stage 3? Well, the thing is, firm uses more variable inputs, okay, to produce less output. Okay, and in stage 1 you can see that you are underutilizing fixed input, so you can increase output per unit when you increase the amount of variable input. All right, okay, so far, okay, all you can identify is the intervals or the range in which a company should hire labor. Okay, but you don't know exactly how many labor to hire. Okay, so this brings us to another section that would be optimal level of variable input usage. Okay, so what we have here is a production table. Okay, so we have variable inputs labor. Okay, we also have the corresponding value for total product, average product, and marginal product. Okay, now based on this value, can you identify where exactly is stage 2 production? Now, if you can recall, okay, from our previous stages of production, stage 2 started from the maximum of average product. So that means after the maximum point of average product, that's where your stage 2 begins. And stage 2 stops at the point whereby total product is at the maximum point. So if you want to identify where exactly is stage 2, what you need to do is, first of all, focus on the average product. Okay, so as you can see here, as input increases, average product increases up to the maximum point of 15,000. Now after 15,000, you can see that average product starts to fall. So if you can recall, okay, when we talk about stage 2 begins at the point whereby average product starts to fall. So meaning that after the 4th units, okay, of labor, this is where stage 2 begins. Okay, now what would be the last point for stage 2? Now again, okay, if you refer back to the stages of production, the last point for stage 2 is actually at the point whereby total product is maximized. So when you look at the total product column, okay, you can see that the maximum point is 80,000. So this basically shows that, okay, the last point in your stage 2 production would be 8 units of labor. So again, okay, where exactly is stage 2 production? So stage 2 production is represented by the values in the red box. Okay, all right, so as I said, okay, we would like to know what exactly is the number of labor or variable inputs that we want to use. Okay, because so far we just know the range. Okay, so we don't know exactly how many labor to hire. So to answer this question, okay, you need extra information. Okay, so what sort of information do you need, okay, to identify the exact number of labor to hire? So the information would be in terms of the price of the product and also the cost that you pay for your variable input. Okay, so if we want to determine the optimal input usage, okay, so we need to assume that, okay, the firm is operating in a perfectly competitive market, okay, and the price of the product is equals to $2, okay, and we're going to assume that the price of your variable input, in this case W, is 10,000. Okay, so let us define, okay, total revenue product, okay, as total output multiplied by price. Okay, so marginal revenue product, okay, is the change in total revenue product when you increase additional labor. Okay, so in other words, when we talk about marginal revenue product, you need to multiply price of the product by the marginal product. Okay. Now, when we talk about the cost, okay, of your variable inputs, in this case, the total labor cost. Now, total labor cost would be price of labor multiplied by how many labor you use. So, basically, W multiplied by L. So, if you want to know what is the marginal labor cost, okay, that means the extra, okay, cost, okay, when you add in one labor. So, this is actually equals to W. So, when we want to know the optimal use of the variable input, so this is the formula that you need to use. Okay, so you need to know what's the marginal revenue product, which is simply marginal product times price. You also need to know your marginal resource cost, which is actually your wage rate. So, the optimal use of labor can be found by equating marginal revenue product with marginal resource cost of labor. Okay, so graphically, okay, your optimal points is the intersection between your marginal revenue product curve, represented by this downward sloping curve, and the perfectly elastic marginal resource cost curve, represented by the black line. So the intersection is what we call as the optimal points of labor. Okay, so let us go back to our production table, but this time around, I have added in extra columns. Okay, so we have total revenue product, marginal revenue product, we have total labor cost, marginal labor cost. We also have the difference between total revenue product and total labor cost, and also a column for the difference between marginal revenue product and marginal labor cost. Now, if you can recall, our stage 2 just now is from 4th unit of labor up till 8th unit of labor. But stage 2 only provides us with the range of labor to hire. Okay, so if we want to know exactly how many labor to hire, as I said, we need to have information on price of the product and the wages that you pay for the workers. And we have assumed that price is equals to 2 and the wage rate is equals to 10,000. So based on the optimal condition just now, okay, the optimal number of labor is achieved when marginal revenue product is equals to marginal resource cost. In other words, marginal revenue product minus marginal resource cost is equals to 0. So if you look at this column, okay, marginal revenue product and marginal labor cost, you can see that the two values are equal, okay, at 10,000. And at 10,000, the number of labor is 6. Okay, and as you can see, at 6 units of labor also, the difference between marginal revenue product and marginal labor cost is equals to 0. Okay, so this shows that if you want to hire labor, okay, the optimal number of labor should be 6. But this can only be achieved when you have information on price of the product and also the wage rate. Okay, so when we talk about the optimal level of variable input usage, remember that, okay, we are assuming that the firm is operating in a perfectly competitive market. Okay, so to identify the optimal number of labor, they will produce at the point whereby marginal revenue product equals to marginal labor cost or marginal resource cost. Okay, so what we have looked so far is we have looked at the production process in the short run, and our main aim is to identify the ideal number of variable inputs to use. Okay, because in the short run, we are using both fixed input and variable inputs. So nothing much can be done on fixed input. All you can do is you can only add variable inputs to get more output. So the question is, what is the ideal number of variable inputs to hire? Well, the stages of production provide us with the ideal stage of hiring your variable inputs. So as you can see, stage 2 is the most ideal stage. Okay, so it starts from the maximum point of your average product up to the point whereby total product is maximized. Alright, but the stages of production only provide the intervals for ideal number of variable inputs. So it doesn't tell the firm exactly how many labor to hire. So if you want to know exactly how many labor to hire, then as I said, you need to have information on price of the product, okay, and also the cost that you pay for each variable inputs. Okay, so by having this extra two information, so the optimal level of variable input use can be found by equating marginal revenue product with marginal resource cost. Okay, so that is for production in the short run. We're gonna try some exercises here. Okay, so all these exercises actually test, okay, your understanding on the concept that I have shown just now. Okay, saya tak nak stop kejap. Okay, sebab yang ni I rasa kena pergi dekat words. Sekejap. Okay, we're going to try a few exercises, okay, to test your understanding on the short run production concept. Okay, so what we have here is a production function. Okay, this is a short run production function because as you can see, okay, the firm is using two types of inputs, okay, capital and labor, but capital is said to be the fixed input. Alright, and labor, you can see that it is allowed to vary with the level of output. Okay, so Q here actually represents the output level and L is the labor units. Yeah, so we want, okay, so if you look at the first question, it says here, at what level of labor input is the marginal product of labor maximized? Okay, so in other words, okay, the first question, okay, wants you to identify the number of labor, okay, when marginal product is maximized. Okay, now if you can recall, in chapter 2, when we learned about optimization, whenever we want to maximize or minimize a function, what you need to do is you need to differentiate the function and set it equals to 0. So here, okay, for the first question, as you can see, what we plan to do is we want to maximize marginal product. So this simply shows that you need to differentiate, okay, marginal product and then set it equals to 0. Now to differentiate, okay, the marginal product, okay, you need to first, okay, derive the marginal product, because looking at the questions, there is no function given for marginal product. So the functions that you have here is only total product or the output function. Okay, so if you are asked, okay, to maximize marginal product, you need to have the marginal product function first. Okay, so the question is, how do we derive to the marginal product function? Now, looking back at the formula, marginal product, okay, is defined as the change in total product divided by the change in quantity, okay, which is also the same thing as the derivative of the total product function, okay, with respect to your independent variable L. Okay, so to find marginal product, what you can do is you can differentiate, okay, the Q function with respect to L. So if you look at the production function, you can see that they have an exponent. So you have to use the power function rule to differentiate it. Okay, so when you differentiate 0.3 L squared, okay, so using the power function rule, you have to bring down the exponent 2, write down the original function 0.3 L squared and reduce the exponent by 1 unit. So that will give you 0.6 L. Okay, now the second component, which is 0.005 L to the power of 3, when you differentiate, again you need to use the power function rule. Okay, so the derivative of that is going to be 0.015 L to the power of 2. So your marginal product, okay, is actually 0.6 L minus 0.015 L squared. Okay, so I hope that, okay, by now, okay, you are very fluent with the concept of differentiation, and you can differentiate, okay, any kinds of function very fast. All right, so that's the most important thing. Okay, so what do we need to do next? Okay, so you need to go back to the question. Now the question says, what level of labor input will marginal product maximize, which we have translated into this term. Okay, so you can see that you want to maximize marginal product, you have to differentiate marginal product and set it equals to 0. So let's take this condition. Okay, so because we want to maximize it, it says here you need to differentiate marginal product. So where is your marginal product? Well, these are your marginal product. So you were asked to differentiate it. So let's differentiate it. Okay, so differentiating it will give you 0.6, okay, minus 0.03 L. Okay, and you have to set equals to 0. Now you start questioning why you need to differentiate twice, isn't it? Now remember that when you look at the question wants you to maximize marginal product. Maximization requires you to differentiate the function once and set equals to 0. Now before you can differentiate the function, you need to identify whether or not the function is available. While looking at the questions, the function for marginal product is not given. So first step requires you to find marginal product function. Now in the lecture, you were told that marginal product is the derivative of the product function with respect to L. So the first time you differentiate is to actually deriving the marginal product function. Now when you look at the question again, okay, remember you are asked to maximize the marginal product function. Okay, so this requires you to differentiate the marginal product function. So why are you required to differentiate for the second time? So the second time you differentiate is to maximize the marginal product. So when you solve this, okay, you're going to get 0.6 equals to, so negative 0.03 L, you bring it to the right hand side, will give you 0.03 L. Okay, so what I'm going to do is, since I'm more comfortable having L on the left hand side, so I'm going to rearrange it. Okay, so 0.03 L equals to 0.6. So basically these are the same thing as this, so you just switch, okay, to the different sides. So if you want to find L, what you need to do is you need to divide both sides by 0.03. So when you divide the left hand side by 0.03, so that's where you get L, and the left hand side of the right hand side of the equation, when you divide by 0.03, okay, that will give you a value of 20. Okay, so this means if you want to maximize marginal product, the total number of labor should be 20. Okay, so that's how we answer question number 1. Now let's proceed to question number 2. Now it says here, at what level of labor is marginal product of labor equal to the average product of labor? Now, if we go back, okay, to our stages of production, okay, now as you can see here, okay, when average product, okay, equals to marginal product, okay, that happens at the point whereby average product is maximized, isn't it? Okay, so when average product here is equals to marginal product, which is actually at point H, okay, average product is maximized. So if you want to know what is the point whereby marginal product and average product is equal, you can find the value by looking at the maximum point of your average product, because at point H, average product is maximized. So let's go back to our question just now. Okay, so because marginal product equals to average product, okay, at the point, okay, where average product is maximized, so to identify this point, what you need to do is you need to maximize average product. So maximize average product requires you to differentiate average product with respect to L. Okay, and then once you have differentiated, you have to set it equals to 0. So now, okay, when we want to differentiate average product, you need to have the average product function. Yet again, if you look at the question, you are only given the total product function. There is no average product function. Okay, so this means you need to first of all derive the average product function. Once you got it, then you can answer the question. So let's find average product. Now, in the lecture, I have already informed you that average product is total product divided by the number of variable input. Okay, and because your total product here is represented by a function, so this is your function, isn't it? Okay, so put that in. Okay, and okay, you have to divide it by L. Okay, so what do you need to do here? Well, you need to divide each of the component of Q by L. So 0.3 L squared, when you divide by L, that will leave you with 0.3 L. Okay, minus sign, you write again the minus sign. And 0.005 L to the power of 3, when you divide it by L, you will end up getting 0.005 L to the power of 2. Okay, so this is your average product function. Okay, so remember, to derive to the average product function, all you need to do is get the total product function and divide it by L. Okay, so now once you get the average product function, you can go back to the question. So what does the question want? The question wants you to find the point whereby average product is maximized. Okay, so average product is maximized when when average product is maximized, you have to differentiate average product and set equals to 0. So to differentiate average product, you need to have the average product function, which is this. So let's differentiate it, and you're going to get 0.3 minus, so if 0.005, okay, you differentiate it, that will leave you with 0.01 L. Okay, and you set equals to 0. Okay, so if you simplify this further, you're going to get 0.3 equals to 0.01 L, because when you bring negative 0.01 L to the right hand side, so you have to cancel off the negative sign. Okay, so this can also be written as 0.01 L equals to 0.3. Okay, so L is going to equals to 0.3 divided by 0.01, and that will give you 30 units. So if you want to maximize average product, now the labor should be 30. Okay, now so far what we have done is we have identified the number of labor that maximize marginal product and the number of labor that maximize average product. Now let's look at the third question. Now the third question wants you to find out at what level of labor is total output maximized. Okay, so if you want to find labor, well, total output is maximized. Okay, so in other words, you want to maximize Q. Maximizing Q requires you to differentiate the Q function and set it equals to 0. Okay, so to differentiate the Q function, you need to have the Q function, and since the question have already given you the Q function, so you wouldn't be having any problem to differentiate it. So this is your Q function. Okay, so if you look at this equation, okay, dQdL is the formula for marginal product, isn't it? So this is marginal product. How did you find it? You differentiate the Q function with respect to L. So if you look at question C, since you want to maximize Q, it says here you need to differentiate the Q function and set equals to 0. Okay, so in other words, okay, dQdL here, okay, represent marginal product function. Okay, and you have to set it equals to 0. So when you maximize Q, okay, in other words, you need to differentiate the Q function and set equals to 0. So this is the same thing as equating marginal product equals to 0. Now you have already derived, okay, the marginal product function. So let us just copy this down. Okay, so your marginal product function being 0.6, okay, L minus 0.015 L squared, and this value should be equals to 0. Okay, okay, so now the question is, how do we solve for L? Okay, so to solve for the L value, okay, what you need to do is you need to factorize it. Okay, so let us take out 1L, okay, and factorize this equation. Okay, so what I'm going to do is I'm going to simplify this. Okay, and notice that when you cross multiply it, okay, for example, L times 0.6, you're going to get 0.6L minus, you write down the minus sign, and when you multiply L with 0.015L, you're still going to get 0.015 L squared. So what I did here is I tried to factorize the function so that I can solve for L. Alright, so again, this is set equals to 0. So when you want to solve this kind of equation, what you need to do is you need to equate each of this function equals to 0. So for example, one solution would require you to set L equals to 0. Okay, another, okay, would require to set 0.6 minus 0.015 L equals to 0. In other words, you have to set, okay, the things in the brackets equals to 0. Okay, so how do you solve this? So this is the same thing as 0.6 equals to 0.015L. Okay, you can also write it as 0.015L equals to 0.6. So to find the value of L, okay, hang on. Okay, so to find the value of L, so all you need to do is you need to divide 0.6 by 0.015, and that will give you 40. Okay, so if the firm wants to maximize output, then the labor must be 40. Okay, so that's question C. Okay, now let's look at the last question. The last question asks you to determine the range of labor that rational firms should choose. Now we have identified that rational firms, okay, would, okay, hire labor, okay, in stage 2. Okay, and if you recall, stage 2 starts after the maximum point of AP up till the maximum point of Q. Now you have identified that, okay, when average product is maximized, labor must be 30, and when total product is maximized, labor must be 40. So because stage 2 starts from maximum AP to maximum Q, therefore the range of labor would be from 30 up to 40. Okay, so this would be the range of labor. Okay, so that would be the range of labor that a rational firm would hire, okay, in the short run. All right, so that's okay, one examples, okay, whereby you try to figure out production in the short run. Okay, so maybe, okay, you would like to try another question. Okay, now this question, okay, is actually on the optimal number of labor. So this is actually part of the past year question, right? So you have a company, okay, by the name of Watch, okay, and Co. And the production function for this company who's producing ceramic pots is Q equals to 6L squared minus 0.04L to the power of 3. Okay, now Q here represents output, okay, per time period, and L is the number of units of labor hired. Okay, now you were asked to determine total quantity produced if the firm uses 10 units of labor. So as you can see here, based on the production function, if you know the value of L, definitely you will find out the value of Q. So if you are using 10 units of labor, if you want to know how many Q, okay, will be produced, so simply substitute 10 into this production function. Okay, so we have Q just now, okay, equals to 6L squared, okay, minus 0.04L to the power of 3. Okay, so that's enlarge this a bit. Okay, and then so both 2 and 3 are the exponent for L. Okay, so you were asked to find what is the value of Q, okay, when L is equals to 10. Okay, so that's what the question wants. Okay, so to do that, okay, substitute L into this equation. Okay, so let's take again this equation, and what you need to do is replace L by 10. Okay, so just plug all this value into the calculator. All right, so what would be the value of Q that you're going to get? So you will be getting 560. So that would be the total output, okay, where Q is equals to 500. When L is equals to 10. Okay, so output would be 560. Now let's look at the second question. The second question says, compute the level of labor input after which the law of diminishing marginal returns set in. Now remember that law of diminishing return begins after the maximum point of marginal product. Okay, so in other words, to answer question B, if you were asked to identify the number of labor where diminishing marginal returns begins, so you need to find L where the marginal product is maximized. Okay, so this is your question A just now. So we're going to proceed with B. Okay, so for B, you were asked to find L, okay, when marginal product is maximized. Okay, so as you know, okay, similar to what we've done, okay, for the previous question, whenever we want to maximize marginal product, you are required to differentiate marginal product and set equals to 0. But to differentiate marginal product, you need to have the marginal product function, isn't it? So marginal product is not given in the question, but you can derive it. Okay, how are you going to do it? You have to differentiate the production function with respect to L. So if this were your production function and you differentiate it, okay, so let's differentiate 6L squared. That will give you 12L, okay, minus, you write down the minus sign, and when you differentiate 0.04L to the power of 3, okay, you will end up getting 0.12L to the power of 2. Okay, so this is your marginal product function. But we are not done yet. Now remember, the question wants you to find the value of L which maximize marginal product. Okay, and you are told that you are required to differentiate marginal product and set equals to 0. So let's, okay, let's now answer the question. So to differentiate, okay, marginal product, that will give you 12 minus 0.24L. You set it equals to 0. Okay, so solving for L would requires you to, bring one value on the left hand side, okay, and then another one on the right hand side. So you're going to end up getting L, okay, equals to 12 divided by 0.24, and that would be 50. So the law of diminishing marginal returns will begin after the 50 units of labor, because when marginal product is maximized, okay, labor, okay, is 50 units. All right, so the law of diminishing marginal return will begin after, okay, the 50 units of labor. Okay, so that's how you answer question B. Alright, the third one. Now, at what level of labor input is the average product of labor maximized? Okay, again, this is very much similar to the previous question. So, question C wants you to find labor, but which labor? Because when you look at the production curve, there are so many points of labor. Okay, is it labor that maximizes marginal product, total product, or average product? So this question wants you to find labor when average product is maximized. So whenever we want, okay, whenever we want to maximize average product, remember that this is optimization. So you are required to differentiate the function and set it equals to 0. Okay, so before you can differentiate average product function, you have to ensure that the average product function is available. So let's go back to the question. Now looking at the question, you are only given the production function. There is no average product function given. But that's not a problem, because by now you should be able to know what's the formula for average product, isn't it? So to find, okay, the average product function, okay, what you need to do is, okay, so let us look at, okay, so this is your production function just now. So if you want to derive to the average product function, what you need to do is you need to divide, okay, the production function by L. So meaning that, okay, each of this component of production function, you have to divide it by L. Okay, so what are we getting here? So 6L squared, you divide by L, will give you 6L. Minus sign, you write it down again. And 0.04L to the power of 3, if you divide it, that will leave you with 0.04L squared. Okay, so that's your average product function. So, any problems? Do you have any problems to derive to the average product function? So this is pretty much similar to what we did previously. Okay, so remember, if you are given the production function and you want to find what's the average product function, all you need to do is take the production function, divide by L. And in this case, it will leave you with 6L minus 0.04L squared. But we are not done yet. The question wants us to maximize average product. And you have established that if you want to maximize average product, you need to differentiate, okay, average product function and set equals to 0. So let us now differentiate the average product function. So if this is your average product function, if you differentiate it, you're going to get 6 minus 0.08L equals to 0. Okay, so you bring L to one side and numbers to the right hand side. Okay, so when you solve for L, so you're going to get, okay, L equals to 6 divided by 0.08, and that will give you 75. So if you want to maximize average product, then the value of labor must be 75. So the second exercise actually tests your understanding in terms of how to identify the different level of labor at the maximum points. Okay, so one is finding L when marginal product is maximized, and another one is finding L when average product is maximized. And this exercise is very much similar to the one that we did, okay, for the first one. Okay, let us look at the last one for the day. Now this one, okay, will help you to again understand, okay, the concept, okay, of production. Okay, so you are still given a production function, okay, and the first question wants you to explain the law of diminishing marginal returns. Okay, so the law of diminishing marginal returns, remember that it is a situation whereby, okay, as you keep increasing your variable inputs, okay, the contribution of each variable inputs decline. So this is law of diminishing marginal return. Now let's look at the second question. The second question wants you to derive to the marginal product and average product functions. Okay, so marginal product is the derivative of the product function. Okay, so let's enlarge the font a bit so that is much clearer. So given your production function, okay, your marginal product function is going to be 2 plus L minus, so 3 times 0.025, so that will leave you with 0.075 L to the power of 2. Okay, so that's marginal product function. Now, next one, you are asked to derive to the average product function. Now, average product function is when you divide Q by L. So, meaning that you have to divide, okay, each of these component of product function by L. So, 2L divided by L will give you 2. 0.5 L squared divided by L will give you 0.5. Okay, L, okay, and 0.025 L to the power of 3 will give you 0.025 L squared. Okay, so this is how you derive to the average product function. So now that we have derived, okay, the two production functions, marginal product function and average product function, now let's move on to another question. So I'm going to give you an extra question here. So we are still going to use the same production function. Now let's suppose that the product is sold at 20 ringgit, okay, per unit, and the wage rate that you pay for each labor is 40 ringgit. Okay, now you are asked to calculate the units of labor that should be employed in order to maximize the firm's total profit. Okay, in other words, you are asked to calculate the number of labor, the optimal number of labor. So, when we talk about the number of labor, okay, so the number of labor that maximizes, okay, profit is the same thing as the optimal number of labor. So don't worry when you see the term maximizing labor that maximize profit, okay, that is exactly the same thing as optimal number of labor. Okay, so the last question wants you to find the optimal number of labor, and in our lecture just now, to find the optimal number of labor, you have to make sure that marginal revenue product must equals to the marginal resource cost of your variable input. Now, apart from that, you need to have information on price of the product. In this case, it is given as 20. You also need to have the cost for your variable input, in this case 40. Now, so given this value, okay, we are going to find the optimal number of labor. So let us together, okay, find this optimal number. Okay, so marginal revenue product, okay, is defined as marginal product multiplied by price. Okay, and marginal resource cost is the cost of hiring your variable input, in this case wage rate. Okay, now the marginal product here can be represented by the marginal product function which you have derived much earlier in question 2. So you have found out that this is the marginal product function. So we're gonna substitute that in. Okay, so that's your marginal product function, which is 2 plus L minus 0.075 L squared. Okay, and you are asked to multiply it by price. In this case, it is 20. Okay, and this must be equals to wage rate, which is given as 40. Okay, so what do we need to do here? You need to cross multiply. Okay, so 2, you have to multiply it by 20, and that will give you 40. Okay, plus L times 20, that will leave you with 20L minus 0.075 L squared times 20. So let's calculate that in, and that will leave you with 1.5 L squared. Okay, and this should be equals to your wage rate just now, which is 40. Okay, so any problem so far? So what we are doing, we want to remove the bracket, and in order to do that, we have to cross multiply, and this is what I get. Okay, now what I'm going to do is okay, so we have already cross multiply, okay, the equations on the left hand side. So this is the product, and you have to set it equals with 40, which is the wage rate. Okay, so now let us bring L to one side. In this case, we're going to leave L on the left hand side, and the figures, we're going to bring it all to the right hand side. So this will leave us, okay, with, so we're going to have 20, okay, 20L minus 1.5 L squared, okay, and this should be equals to, so you already have 40 on the right hand side, so the 40 here on the left hand side, when you bring it to the right hand side, you're going to have minus 40. Okay, so let's enlarge this a bit so that you can see this clearly. Okay, so what we have done is we have group it, okay, group numbers together on the right hand side of the equation, and label the terms with L. We just leave it on the left hand side. Okay, so let's so we're gonna simplify this further. So 20L minus 1.5 L squared, that will be equals to 0. Okay, so we want to solve, okay, for L, but this requires you to factorize it. So to factorize it, so let's take out L, and then we're going to have 20 minus 1.5 L inside the bracket. But remember, when you cross multiply, okay, for example, L times 20, you're going to get 20L minus, you write down the minus sign, and L times 1.5L will give you back the 1.5L squared. Right, so far we have already managed, okay, to simplify this equation into 20L minus 1.5L squared equals to 0. Okay, so to solve for L, you are required, okay, to factorize, okay, the functions that you have on the left hand side. Okay, so to factorize it, what I did was I bring up L, okay, and in the brackets I have 20 minus 1.5L. So notice that when you cross multiply, you're going to get back the original function. So for example, L times 20, that will give you 20L. Minus sign, you write it down again, minus. L times 1.5L will give you 1.5L squared. And this is equals to 0. Now to solve for L, you have to set, okay, each one of this component. For example, L, okay, the one outside the bracket equals to 0, and the other solution would involve setting the values or the functions, okay, in the brackets equals to 0. Okay, so okay, so you have 20 minus 1.5L equals to 0. So you bring L to one side and figures on the right hand side, and when you solve for L, you're going to get 13.33. So this basically shows you that if you want to get the maximum profit, okay, so the optimal number of labor must be equals to 13. Okay, so this exercise, okay, actually allows you to understand about the concept of optimal number of labor. So to find the optimal number of labor, or the number of labor that maximize profit, well, you have to ensure that the marginal revenue product always equals to the marginal resource cost, and that will enable you to find the optimal number of labor. So what we have done today is we have focused on production theory. Okay, specifically we have looked into production in the short run. Okay, so our main aim is to find the ideal number of inputs, okay, so as to minimize the cost. Okay, because for any firms, okay, managers would like to achieve maximum profit, and to get maximum profit, total cost must be at the minimum. Okay, so to find the method that can ensure minimum cost, so this is where we need to analyze production. Now in production, in the short run, we know that we are using two types of input: fixed input and variable input. Now fixed inputs are inputs in which you cannot change the quantity, so regardless of how many output you produce, but the amount of fixed input remains the same. But when it comes to variable inputs, the quantity varies with the level of output, meaning that the more output you produce, the more variable inputs that you use. If you use less variable input, then you're going to produce less output. So the question now is, given the short run scenario, if you want to identify what would be the ideal number of variable inputs to hire, what would the value be? So to find the ideal number of labor to hire, we have looked into the stages of production, and we have identified that stage 2 is the best stage that a rational producer would choose. So in stage 2, this is where you're going to have the best combination between fixed input and variable input. Now we have also established that stage 2 starts from the maximum point of your average product until the maximum point of your total product. But stage 2 only provide you with the range of labor. So it doesn't tell you exactly how many labor to hire. If you want to know how many labor that the firm needs to hire, so this brings us to optimal number of labor. So to determine the optimal number of labor, you have to make sure that your margin revenue product must always equals to the marginal resource cost. So to use that condition, you have to get information on the price of the product and also the cost of your variable input apart from your marginal product function. So using the condition of MRP equals to the marginal resource cost, MRC, then you'll be able to identify optimal number of labor. So that's basically it for today. In the next class, we're going to look at the long run, and we're going to identify what would be the decision like when it comes to input usage in the short run. So all the best for your short run production. So we're going to meet again in the next lecture. Thank you.